Hi, I'm Patrick Reagan. Welcome to the Computer Primary Components Part 8 Power Supplies. During this video, we will discuss the function of the power supply form factors, energy efficiency of power supply connectors, modular power supplies, redundant power supplies, installing power supplies, and troubleshooting power supplies. Primary function of the power supply is to convert AC power to clean DC power and distribute the power to the various components in the system. Power supplies used in computers are switching power supplies that continuously turn on and off at high frequency. If it needs to provide more current to the various devices connected to the computer, the switching power supply will turn on longer than it turns off. Secondary function of power supply is cooling by providing a fan. Although most electronic devices use DC power, AC power is sent to your house or place of work through the power lines to the AC power outlets. The reason the AC power is sent through the power lines is because it can be sent more efficiently than DC power. In the United States and Canada, the voltage sent is 120 volts AC, typically between 115 and 125 volts, at a frequency of 60 Hz. Most countries outside North America use 220 volt electricity at a frequency of 50 Hz. Don't provide 220 volt electricity to a 120 volt device. The power supply can handle both 120 volt electricity and 220 volt electricity. Power supplies will have a voltage power selector switch or it will auto detect. If you provide 220 volts to a 120 volt power supply, it can cause significant damage, potentially leading to smoke and fire, and forcing you to replace the power supply and potentially other components including the motherboard and processor. If you connect 120 volts to a 220 volt power supply, the power supply will not turn on and usually there is no damage. For more information about electricity, visit the Computer Electricity and Electronics series. Some computers, including mini computers and laptops, will use a power brick to provide external power to the system. A form factor describes the physical dimensions, sizes, and layouts. It also specifies power connectors and airflow. As mentioned before in previous videos, there are form factors for motherboard, cases, and power supplies. The power supplies have to fit into the case properly and has to have the correct connectors for the motherboard and the necessary peripherals. The power supply needs to provide the necessary power to the necessary components. Here's a look at the various power supply form factors. The most common form factor is the ATX power supply that will be found in standard desktop PCs and most tower computers. The SFX is a smaller power supply used in small form factors. Other form factors include the SFX-L, TFX, and Flex ATX. Power is the rate of energy consumption or the amount of energy used in a certain length of time. Power equals current times voltage. Electronics is expressed in watts. The ratings of a power supply specify what is the maximum power the power supply can provide. When you have a power supply that provides power, you cannot exceed the power provided by the power supply. Overload is when you exceed the amount of power that the power supply can supply. If you have too many devices connected to the power supply or battery, the power supply or battery will not be able to provide enough electricity to the load. The computer power supply will shut down or reset if it is overloaded. When you figure out load, you will have to add all of the components' power consumptions to see if your power supply can provide enough power. As you can see, the motherboard with a processor will use anywhere from 15 to 290 watts when you add the two together. Mechanical drives use 6 to 15 watts, while the SSD drives use much less. Graphic cards can use up to 300 watts. Energy efficiency for computer power supplies refers to how well a power supply converts AC power from the wall into the usable DC power for the computer's components. Efficiency percentage is the percentage of the input power that actually gets used instead of wasted as heat. 80% efficiency means 80% is usable and 20% becomes heat. Higher efficiency reduces power consumption, saves money, and keeps the PC cooler by minimizing wasted energy as heat. Energy efficiency equals less energy waste, which equals lower electricity costs and less heat output. 80 plus certification is the standard to indicate efficiency levels. A gold-rated power supply unit is about 87 to 90% efficient at typical loads at 20, 50, and 100%. To power the motherboard, you can connect a 24-pin ATX power connector or similar connector. However, the power supply may also have a 4-pin or 8-pin connector for additional power and or a 6-pin PCI Express power connector for high-end power graphics cards. Lastly, the power supply may provide Molex connectors for older hard drives and SATA power connectors for the SATA drives. Here is another look at the power for the motherboard and SATA drives. If you look closer at the motherboard power connectors, the corners of many of the pins are clipped on the one side and then latched to prevent accidental disconnection. And yet, another closer look at connecting the Molex and SATA power connectors to the drive. Here is the voltage breakdown of the PC power supply. The black wires are ground and the red wires are plus 5 volts. Other typical voltages supplied by the power supply are plus 3.3 volts, plus 12 volts, and minus 12 volts. Almost all of the new power supplies used today feature a 24-pin power connector to connect to a computer motherboard. However, some motherboards still feature a 20-pin ATX power connection. Many 24-pin power connectors are designed so that the 4 of the pins can be detached or moved out of the way. The 24-pin power connector on your power supply does not allow the detachment of the additional 4 pins. You can still connect it to the motherboard's power connector by purchasing a 24-pin to 20-pin adapter. A modular power supply is a power supply that has removable cables. It allows you to remove the cables that you are not using and add cables as you need them with fewer leftover wires in the case. While it provides better airflow, it is generally more expensive than a non-modular power supply. A semi-modular power supply has basic cables including 24-pin ATX motherboard connection, the 6-pin or 8-pin CPU cable, and the PCI Express power connection for the video card. Other cables can be added as needed. It is not as expensive as the modular power supply, but more expensive than the non-modular power supply. Computer power supplies provide a power good signal. When the power supply performs the self-test, testing whether all voltage and current levels are acceptable, it will send a power good signal to the processor timer chip. A soft power button is usually used in computers. Single press can be programmed to do different things, such as cause the operating system to do a proper shutdown or to hibernate or sleep. Holding the button down for several seconds will cause the computer to power off. Power supplies are considered high failure items. For mission critical computers, you can have a system that has redundant power supplies. It is usually found in servers. Redundant power supplies are usually hot swappable, where you can replace the power supply without powering down the computer. Each power supply can handle 100% of the load, but will normally run at 50% of the load. If one of the power supplies fail, the other one can handle the entire load. Make sure that you connect each power supply to a separate electrical circuit in case of your electrical power failure. Consider using a surge protector or uninterruptible power supply or UPS to help protect against power spikes and surges. Power supplies are usually held with 4 Phillips screws. You also need to disconnect or connect the various power connectors. For removal and installation of power supplies, visit the following video, Computer Disassembly and Reassembly, Part 3, Tower Computer. Power supplies are considered a field replaceable unit, or FRUs. If a power supply fails, you should not open the power supply to fix it. The capacitors can hold charges for long periods of time after the computer has been shut down and unplugged from power, which can provide a lethal shock if you don't know how to properly repair high-power devices. Troubleshooting and replacing electronic components, including capacitors, falls to electronic specialists, which requires high level of training and education. In today's electronics world, it's less expensive, much quicker, and much safer to replace the entire failed device. Therefore, if the power supply fails, you would just replace the power supply. Note, power supply units, or PSUs, degrade over time. Even high-quality ones can drift or fail after 5 to 7 years. When troubleshooting power problems, check the obvious and gather basic information. When your system does not turn on when you press the on-off switch, you should. Did the power supply work before, and did you make any changes to the system? On the computer, do you have any lights that are on? Did you smell any burnt smells or heard any pops or crackling? If you heard a pop, you should suspect that you blew a capacitor, most likely within the power supply or on the motherboard. Did you see any flashes of a light, or did the lights flicker before? Verify that the AC power cable is connected properly to the AC outlet in the computer. Verify that you have electricity coming from the AC outlet. Remember, if it's connected to a surge protector or similar device, make sure the surge protector is plugged in into an active socket and the on-off switch is set to on. You should also check to make sure that there is not an on-off switch that controls the wall outlet. Check the power supply voltage selector switch to make sure the current voltage is selected. If you suspect a failed or faulty power supply, perform the following. Make sure you're connected properly to an active power outlet and that the power outlet is providing the correct and sufficient AC power. You can use an AC tester or a multimeter to test AC voltage. If you hear a high-pitched whining or smell burning or plastic, shut it off immediately. If your electricity surges, such as lights flickering, and you have an immediate failure, suspect a damaged power supply or motherboard. Turn off the computer and unplug it from the wall. Open the case and perform the following. Inspect for visible signs of burn marks, bulging or leaking capacitors, loose cables or connectors, and dust buildup, which can cause overheating. Verify that the internal power supplies and wires are properly connected to the motherboard and the various components in the computer. Make sure the power switch wire is connected from the case to the motherboard. If this wire is not connected and connected properly, the motherboard never receives the command to do so if you press the power button. Next, reconnect the power cord and attempt to turn the PC on, looking for any signs of power, including if the fan spins or even jerks a little, any motherboard lights or sounds or beeps. If it is completely dead, suspect a possible power supply unit or motherboard fault. If the power supply fan jerks a little, it could be a power overload, short, or break within the computer system. If you recently added new hardware and the power supply stops functioning, suspect that the power supply cannot provide enough power. If the power supply appears to be functioning, you can use the multimeter to see if the power supply is providing the correct voltage. If any voltage is significantly off by 5 or 10% or more, the power supply unit may be failing. Swap with a known good power supply. If the system boots normally, your old power supply is bad, you should keep using the power supply or order a new power supply. If the computer seems to have a short, open, or overload, you'll need to isolate the problem. This is done by unplugging anything unnecessary and removing the expansion cards and drives. You will then start just with the motherboard, RAM, and processor. If it does not work, suspect that you could have a faulty power supply, motherboard, RAM, or processor. Then connect one device at a time and test again. If you get to the end and you connect the last device and it fails, you should suspect that the last device you connected or that you have reached an overload. Question: what is the primary purpose of the power supply? Answer: to convert AC to clean DC power and distribute power to the various components inside the computer. Question: what voltage is applied to the AC outlet in the United States? Answer: 115 to 125 volts at 60 Hz. Question: what is the most widely available power supply form factor? Answer: ATX. Question: fill in the blank. Power supply capacity is measured in what? Answer: watts. Question: what is it called when you connect too many devices to your power supply and the power supply does not start up? Answer: an overload. Question: today, how many pins does the standard ATX power supply connector have to the motherboard? Answer: 24. Question: when looking at power connectors, what is the black wire? Answer: ground. Question: a common connector type providing power to graphics cards, CPUs, older type of storage media, or cooling fans on the motherboard is generally referred to as what? Answer: Molex connector. Question: which motherboard connector features an L-shaped design that prevents its improper insertion? Answer: SATA. Question: which of the terms listed below refers to a server load balancing setup in which supplied power is split between multiple power supply units? Answer: redundant power supply. Question: A user needs to upgrade the power supply of an older workstation to properly power a new graphics card. Which of the following criteria should the technician check to ensure the power supply will support the upgraded workstation? Choose two answers. Answer: wattage and form factor. Question: true or false? Modern ATX motherboards use a 24-pin power connector. However, many power supplies might be equipped with a 20-pin power connector for backward compatibility with older motherboards and a separate 4-pin connector for delivering power to PCI Express slots on newer motherboards. The 20 plus 4 connector can be used with either 20 or 24-pin motherboards. In case of the 20-pin motherboard power slot, the 4-pin connector simply remains unattached to the board. Answer: true. Question: true or false? The term modular power supply refers to the power supply unit equipped with detachable cables. Answer: true. For more information, visit these sites. In summary, primary function of the power supply is to convert AC power to clean DC power and distribute the power to the various components in the system. Secondary function of the power supplies is cooling by providing a fan. The power supplies have to fit into the case properly, it has to have the correct connectors for the motherboard and the necessary peripherals, and it needs to provide the necessary power to the necessary components. The most common power supply form factor is the ATX power supply. Power is the rate of energy consumption or the amount of energy used in a certain length of time, which is in watts. When you have a power supply that provides power, you cannot exceed the power provided by the power supply. Overload is when you exceed the amount of power that the power supply can supply. Energy efficiency for computer power supplies refers to how well a power supply converts AC power from the wall into the usable DC power for the computer's components. To power most motherboards, you could connect a 24-pin ATX power connector or similar connector. Power supplies are considered high failure items. Thank you for watching this video. This completes the Computer Primary Components series. The next series will be Storage Devices. If you have not already, subscribe to the Pat Has Your Back channel. Thank you.